पीरियड स्टार्ट हो गया
Why the strength is so less today? Okay. So keep your mask on. Sitting on the first bench. Any doubts from yesterday? Any doubts from yesterday? No. So today I will be covering the concept of symbol is R. So what is it? It is resistance is the obstruction to flow of current. Okay, it is the obstruction to flow of current. So what happens? Since current flows is due to charge flow, is electrons. Which charge? Electrons, right? These electrons suffer collision with positive ions in the conductor. In the conductor. Okay. So if the temperature increases, these ions also vibrate, so they obstruct the path more. So with rise in temperature, the resistance increases. Right? So if the number of collisions is more, it offers more resistance. If the number of collisions are more, then there is more resistance to the flow of electrons and hence current. Okay, so just read and understand what it is. Current flow is due to charge flow. And what charges? Electrons. These charges suffer collision with the positive ions in the conductor. If the number of collisions are more, then there is more resistance to the flow of electrons and hence current. So suppose we have an enlarged view of conductor. It is full of positive ions and electrons. Right. So let us say the current is flowing from left to right. Let's say this is the direction of flow of current. And what is the direction of flow of electrons? So like this will go from current direction left to right electron. Because I have drawn the electron. Let's say this is the direction of flow. Then the electron will flow in this direction, let us say. So it collides, then God knows where it will go, like that. Okay. So likewise, this electron collide and then the direction changes, right? So it travels in all the directions and it will suffer collision with positive ions. Okay, because of which there is resistance. It's not a free flow of electrons. So it depends on the type of substance. In some substances, there are more and more free electrons, so the current will be more. Right? So, some substances offer less collision as compared to other substances. Right? It means it will have less resistance. So if the resistance is less, then the current flow will be better. Resistance basically obstructs flow of charge and hence current. So if the resistance is less, it means it will have less resistance. Right? Okay, so it depends on different substances. So a better conductor should have less resistance or more? Yes. A better conductor has less resistance. ठीक है, मीनिंग उसमें क्या हो रहा है? Collisions कम हो रहा है. So what is the unit of resistance? The unit of resistance is ohm. Is ohm. This is the symbol. So here you should connect. Will the electron flow by itself? You need a potential difference, right? Then only. Because the electron is flowing from left to right. This side is negative. This side is positive. And it will be going from left to right. What is the current direction in this? Right to left. This is the current direction. Shown. increase index. Because current will only flow when there is potential difference. On a piece of wire on its own, there will be no current. Can I erase the left side? Next is Ohm's law. So, what is Ohm's law? It gives the relation between the applied potential difference and the current flowing through the conductor. Okay? So, Ohm's law, it gives the relation between the applied potential difference across the conductor okay, across the conductor and the current flowing through it. Okay, so what are we seeing? Whenever we have a conductor and when there is a potential difference applied, there will be current through it. So, whatever is the resistance offered by this conductor is, let us say, R. Symbol for resistance is R, right? So, what is the statement of Ohm's law? It says, it states that the current flowing through the conductor is directly proportional to the potential difference applied across it. Provided its temperature remains same. Okay, so as long as the temperature of the conductor does not rise, the applied potential difference will lead to increase in current. That is, I is directly proportional to E. This is the Ohm's law. Meaning, if we increase this voltage, the current should linearly increase. Or I is equal to V by R, where R is constant. What? Resistance of the conductor. Okay. So how do we write? Therefore, R is equal to and this is constant. we draw the resistance? The symbol for resistance is this. This conductor will be drawn like this now. Okay? So we don't draw every time such bulky diagram. The same conductor is represented as R. Because every conductor has resistance. Let's now do experimental verification of Ohm's law. Saturday she does not cover. Last time also Saturday she did. Probably she has some other class. So experimental verification of Ohm's law. Everybody signed the attendance? Where is attendance? Sandeep? Attendance? Sign किया हम लोग ने? कोई नियम बच्चा है क्या? So for verifying this, that I is proportional to V, okay, or V is proportional to I, we will plot a graph of I versus V, and it should be straight line where it is proportional, right? Yes. So how do we verify it experimentally? For that we will require a circuit. So following circuit will be used. Will be used to verify Ohm's law. Okay, so experiment में क्या करोगे? You will take a resistance, then you will apply a cell, because cell is the source of current. Okay. Then you will have one jockey like this. So this is a variable resistance. So this is the fixed resistance R, the conductor, right? And this is what we call RH, rheostat. Great. So this can be moved on this. So when it goes from left to right, the resistance of the circuit increases. So less current will flow. Okay. So that way you can control the current flow through the circuit. This is how the current is flowing. Now we need to measure what is the voltage across this resistance and what is the current flowing through it. So for that will be meter. So we will connect voltmeter here to note down what is the potential difference across the resistance, and we will connect a ammeter here to measure what is the current flowing through the resistance. Is it clear? So, and how will we vary the potential difference? We can by moving this. Okay. So using this, I am controlling the current flow through the resistance, and then you will see that the values here are changing. Okay. So for different positions of this, right? RH is rheostat, or it's called variable resistance. Okay. So this is called jockey, this arrow, and you can move it. You must have seen it in the lab, have you? Have you done Ohm's law experiment? Okay, so when you will do that experiment, it will become clear. So now suppose various values are on, let us say, so V in volt and I in ampere is noted. Okay, so you will slowly increase the voltage and note down the current. Let us say you have 3-4 values. Let's say initially your voltage was 1 volt, 2 volt, 3 volt, 4 volt, right? So current in the circuit flowing is, let us say, 0.1 ampere, 0.3 and 0.4. Okay, so now you can plot the graph. So plotting I versus V, I versus V graph. So in the lab you obtained all this value, right? How did you obtain? By writing this. Note down the reading here. This is voltmeter, this is ammeter. How do you connect? This is positive, so you will connect positive here, negative here. This is negative, so this terminal should be negative, this is positive. On the meter there are markings. So depending upon how your cell is connected, accordingly you will connect current meter and voltmeter. So what is this meter? This is called as ammeter, connected in series. In series with R to measure current through it. So where is the current passing? Through R. So whatever is the current passing, it will note down. What is V? V is, it is a voltmeter. Okay? Connected in parallel with R. Remember this, how it is connected. Connected in parallel with R. To measure potential difference across it. So this is only for your understanding. You will not draw this. Okay? Just what is V and what is A and how they are connected. V is connected parallel to the resistance. So this is called parallel connection. Resistance and volt across 2 points. So this is called series type. So first resistance and then ammeter. It is called series connection. Is it understood? What is series connection and what is parallel connection? So in parallel, you put the meter across it, across 2 points. In series, just one end will be connected, other in the conducting path in the circuit. So what is a circuit? How do you define a circuit? Circuit is a closed conducting path. Electric circuit. Is a closed conducting path in which the resistance is also called a load, the source of current this source of current, cell or battery. Or current. So it must be a closed conducting path. This is what we call electric circuit. So what all is connected? You have resistance and then you have cell at least. So this is V. Okay. So what is now IV graph? IV graph is you put I on the y-axis and V on the x-axis. So choose the scale and plot the readings. So this is 0, you have 1, 2, 3, 4, 5 volts. Let's say you have one more reading, 5 and 0.5. Ampere and just hold it. So when you plot the graph, all the points will appear. So you're getting a straight line passing through the. That means this relation is verified. So when we increase voltage, current is increasing in same proportion. Right? That is, so the straight line proves that I is directly proportional to V. So the Ohm's law is verified. Correct? There is a linear way. Hence, Ohm's law is verified. Are you all with me till here? So it is experimentally verified also. Can we find the value of resistance through this graph?
Yes.
How? Because R is V upon I. So if we take the slope of the graph, the reciprocal of the slope will be resistance. Because slope is I by V, right? So if I take the slope of this graph, let's say I take this slope. So this will give me delta I. This is how much? 0.4 minus 0.2. Right? And this will give me delta V. How much is that? Delta V is 3 minus 2. 1 volt. Delta I is 0.4 minus 0.2. 0.2 ampere. The slope of IV graph gives, right? Therefore, slope of IV graph is equal to delta I upon delta V. Right? Which is equal to how much? For this case, it is 0.2 upon 4 minus 2, right? It's 4 minus 4 minus. 1, 2. Okay. You know how to calculate slope, right? Yeah. So how much is this? So this is like 1 by 10, right? 1 by 10. So what will be resistance?
10.
Therefore, resistance is equal to delta V upon I. This is equal to 1 by, so R is equal to 1 divided by 1 by 10. Understood how to find resistance using Ohm's law. Using this experiment, you can always find the resistance of any given conductor. Okay. We could have plotted VI graph also. In that case, V would be on y-axis and current will be on x-axis. So for a VI graph, resistance is directly slope of the graph. But for an IV graph, resistance is reciprocal of slope of graph. Okay? So note. In case of VI graph of a conductor, right? Resistance is equal to slope of VI graph. Because in this case, you will get directly delta V by delta I. Whereas in IV graph, we got delta I by delta. The slope was delta I by delta. Is it clear? So, this is a small variation. So, have you understood what is Ohm's law and how to experimentally verify it? So, it should be simple. Now, let us understand what are ohmic devices and non-ohmic devices. So, all the devices which obey Ohm's law, they are called ohmic devices. Okay? Meaning, for all the devices, like what is the device which R is shown? This could be any device. Okay? Any electrical device. So, for all the devices for which, when we plot a graph like this, if it is a straight line, that means it is obeying Ohm's law. All such devices are ohmic devices. There are certain electrical devices for which the graph is a curve, not a straight line. Then they are called non-ohmic devices. As simple as that. Okay. So let's understand what is ohmic device and what is non-ohmic device. You have written everything, no? Here.
Yes. So
devices, omic and non-omic. All the electric devices. Which obeys Ohm's law. Obey is correct. E-Y, right? Obeys Ohm's law. Okay. Or called ohmic device. Okay. That is, for these devices, the VI graph will be straight line. These are the problem. That is, for ohmic devices, the IV or VI graph should be straight line. Okay, showing direct relation between current and voltage. So if the line is curved, then it is non-homogeneous. Non-homogeneous devices do not obey Ohm's law. That is, where IV or VI graph is not a straight line. Okay, so now I'm giving you two graphs. One is like this, this is tell me which graph is ohmic and which is non-ohmic.
That is ohmic and this is non-ohmic.
Okay, so it's simple. Can I erase left side? So now that you know what is, so what is 1 ohm then? What is 1 ohm resistance? Since R is equal to V by I, therefore so how do we define 1 ohm? Is everybody done writing? How do we define 1 ohm? How to define 1 ohm? What is 1 ohm resistance?
1 volt required to send 1 ampere.
So this can be written as V is equal to IR. So there are 3 formulas. Or I is equal to Vy. So all these are Ohm's laws only. It can be written in these 3 ways. V equal to IR or I equal to V by R or R is equal to V by A. Okay. So how do we define 1 ohm resistance? So when a potential difference of 1 volt is applied across the load or resistance, okay, leading to a current of 1 ampere through it, then we say the resistance of the conductor is 1. Okay? If the resistance of the conductor is 1 ohm, then when 1 volt is applied across it, it will flow the current of 1 ampere. Okay? So a resistance of conductor is said to be 1 ohm when the unit current flows through it. While the unit potential difference is applied across. Understood? So then we say the resistance is 1. So mathematically it's very simple. 1 ohm is 1 volt divided by 1 ampere. In English, 2-3 statements in writing. Okay. Now let us cover factors on which resistance depends. So can you tell me what are the factors?
Shape and size of the material.
And shape and size later. First, what did I tell you? The nature of substance. In some substances, the collision will be less. In some substances, the collision will be more. So first is nature of substance. Second is length of the conductor. Third is area of cross section. Of the fourth is temperature of the room. Okay, these are the four things on which resistance of the conductor depends. Nature of the substance. Like copper will have different resistance, silver will have different resistance. Okay, iron will have different resistance. Like that. So whenever you change the substance, it will have different resistance. So when you increase the length, right, resistance is directly proportional to the length of the substance. So if length doubles, resistance also doubles. And area of the cross section of the conductor, resistance is inversely proportional to the area of cross section. If the area increases, resistance will decrease. So if the conductor is thick, its resistance will be less for the same length. Right? So here, if the temperature rises, resistance also increases because the collision increases. Right? So with rise in temperature, the resistance of conductor increases. Due to increased number of collisions. Between electron and positive ions of conductor. So I have shown and explained it many times. Right? Have you written it?
Yes.
Now the last topic for today. Do we have any online student?
Yes. There was one.
Huh?
Now it's not.
There was earlier?
No.
Okay. Factors on which. So now let us do the concept of specific resistance. What is specific resistance? Rho. So if the length increases, resistance increases. If the area increases, resistance decreases. Right? If the temperature increases, resistance increases. So for Ohm's law, we are assuming that the temperature will not rise; it will remain constant. Okay. So here, since R is directly proportional to L and R is inversely proportional to area, right? So when we combine it, therefore R is directly proportional to L by A. So when we remove the proportionality, it is rho L by A. Okay. So rho is a characteristic constant. For a given substance. Okay. That is called specific resistance. Of the substance. So what is specific resistance? Now we know that the resistance of the given substance is not a constant. It changes with the dimension. So first write down the analysis. Have I covered too much today? No, it's okay, right? It's going inside, right? I feel that I've gone a little fast today. Keep it. Lecture time up. 5 minutes, right? Alert, huh? Lift catch mode on. Okay. So what is this row? Specific resistance, right? Everybody done writing? So for the same substance, if its length increases, the resistance changes. If its area or thickness increases, the resistance changes. So resistance for the same substance is not a characteristic constant for it. It changes with its dimension. Right? Resistance changes with the dimension. So what then does not change for a given substance, which is independent of the dimension? Specific resistance. Specific resistance for a given material is constant. It will not change with its dimension. Okay? Why? See, what is specific resistance? If I take L equal to 1 and A equal to 1, so R is equal to rho if L is equal to unit length and A is equal to unit area of cross-section. If I put L equal to 1 and A equal to 1, then I get R is equal to rho. So what is the definition of specific resistance? It is numerically equal to the resistance of conductor of unit length and unit area of cross-section. That is how we define specific resistance. So it will be same. Okay? Because it is defined only for unit length and unit area of cross-section. Got it? So there is a chart given in your book for various substances. Specific resistance of some substances at 20 degrees Celsius. So many of them. So now each conductor has been provided with a definite value of specific resistance. So you will see for metals it is less. Okay, for insulators it is very high. Okay, and for alloys it is in between. So generally the specific resistance of alloy, right, it is higher than metals. Then you have semiconductors. Can you see the table? So for semiconductor values lie between metals and insulation. Okay. Are you waiting for me to go? Okay. So let's define this specific resistance. Definition of specific resistance is of a given substance is resistance of its unit length and unit area of cross-section. What it specific resistance is this L1 A1. You get specific resistance of the given substance is resistance of its unit length and unit area. Okay, and it is a characteristic constant. Okay. All right, so it is time. We'll elaborate it in next class. Okay, see you next class. Thank you.
हाँ हाँ